speed, guys, of 12 meters per second during a time interval, here's where most people messed up, of 4.0 milliseconds. What average force acted on the ball during this time?
Net force.
So the mass is 0.53 kilograms. The velocity was 12.0. Now it's actually just 12 meters per second, two significant digits again.
Times
0.0 milliseconds. And the time was 4.0 milliseconds or 0.004 seconds. Is that correct? Did I move the milliseconds right?
Oh, yeah.
Gets much smaller.
meters per second.
Thank you. Thank you. You're right. With the slash, it's meters per second. Excellent catch, Janan. Thank you. So that's milliseconds. Now the acceleration is velocity over time. So that's 12 meters per second divided by 0.004 seconds. Someone please double check me, but I believe this is 3,000 meters per second squared.
If you had 3 of those, you'd have about
3,000.
Would. That's true.
3,000.
So that's 3,000 meters per second squared. That's an amazing acceleration.
Lost the game.
Now, what average force acted on the ball during this time? Force is mass times acceleration. So the force is 0.53 kilograms times 3,000 meters per second squared. Give me my newtons. So that's 1,000. It's 1,590 newtons. But how many significant digits did we have?
Did you do that in your head?
2.
Yeah. 2 significant digits. So it's 1,600 newtons.
So wait, I'm still trying to...
Is the force in that time. Any questions on that?
What time is it?
I have no idea. We got one more of these. Almost done, guys.
Oh, wait, don't erase the that side.
Can you,
Force.
the next problem, can you just shorten it into 2 lines? Because I have 2 lines left.
I'll do what I can. I don't think so, but I'll try.
Time out. Don't erase that part.
Okay, I'm not erasing that part. Okay, number 6. Take a moment.
Okay,
Collect
erase
yourselves.
Why did you put a dot and a parentheses?
I took a course in redundancy. I took it twice. I liked it so much.
Wait, make that joke you got? I zoned out for a sec.
I like that joke so much I'm going to tell it again. No, I'm not. Okay.
No, you're not.
Number 6. This requires you to remember a formula we hardly used last semester. Number 6, excuse me. A 92 kilogram water skier. It's basically my weight. No, it's not basically my weight. It's basically my mass. You all should have caught me on that, actually. It's got myself.
We didn't want to call you fat.
Thank you. I appreciate that. An 890 Newton water skier on planet Earth, somewhere near sea level at least,
Wait, he's on a mountain.
is floating in a lake, is pulled from rest to a speed of 12 meters per second at a distance of 25 meters. Once again, we have to find the acceleration to find the force.
Do you use an orange form?
But how do you do it if acceleration
Wait, do you
equals v over t and we don't have t?
But see, because there was another formula that we used sometime last October. Well, like 3 times. But okay. Guys, who remembers, and this has been on every test, who remembers v squared
Equals it.
minus v initial squared,
Equals.
2a times x minus x initial? Do you remember that one?
I will
We've
not
never,
lie. I
like,
do know,
we've
but-
seen that, but we've never used it.
You had to use it twice on one test.
Oh, well,
There's one time.
Why do you
I need
remember
to
that?
use
Yeah, it was. No,
about it.
I remember the test. It was the is the runway long enough for the jet to take off?
Right.
Am I
It was
in?
actually just an airplane. It wasn't a jet.
Yeah, same test but started with Superman jumping.
Is that the one
the building.
Is that the one
Yeah.
where Tinkerbell cheated on Peter Pan?
No, there was one after that.
I was really mad at that one.
Okay, now,
Tinkerbell.
War.
okay, so with this equation, guys, this relates velocity distance, and acceleration. And you're being asked to find an acceleration, Janan and Johannes, knowing a distance and a velocity. So my final velocity is 12 meters per second, and that's getting squared, minus an initial velocity, it started from rest, this water skier started from rest, of 0 meters per second squared, equals 2 times the acceleration, that's what we're looking for. He wound up going 25 meters after starting, we're calling his starting point 0 meters. Think we can use this to find the acceleration?
Yes. You can, because it's all there.
It's all there. So we have
144.
144 meters squared over seconds squared is going to wind up equaling 50 meters times the acceleration. The units will work out because we can divide by meters on both sides, and we're going to get 144 over 50 meters per second squared is the acceleration. 2.88?
What's the significant digits?
It's 2, but we can wait till the end
Equals what? Oh,
if we want. So the acceleration is 2.88 meters per second squared. And the question was, what force would be required to pull this water skier along like this? So force equals mass. Yep. 92 kilograms times 2.88 meters per second squared. That gives us our newtons. So what's the answer to 2 significant digits in newtons?
260 newtons.
Yeah, 260 newtons. Remember what a newton is. Amount of force required to push 1 kilogram, accelerating it in 1 meter per second squared.
that's how I roll.
Mr. Melville,
Yes.
what do they put into, like I was listening, but what do they put into calculators to make it like liquid screen?
I'm not all
Put
sure.
in your brain and make it ask
It's a
irrelevant,
liquid
stupid
screen.
question.
That's a relevant
Finish
question.
the
It's a
test.
good question, but but for last time, any
Yeah.
questions on number 6? Going once,
Crap out of you.
going twice.
Don't erase it, but no.
Don't erase it. Okay.
Frenzy.